Hello, my friends. In this video, we'll be taking a look at the autosomal DNA results, predicted phenotype traits, and GD match results of an individual from the Bacho Kiro Cave in Bulgaria. This is where this cave is located. It is in central Bulgaria, right here. And now let's move on to their results with trait predictor and their um, haplogroups, right? So we're going to start with the haplogroups. Mitochondrial lineage is U8, and that is confirmed with James Lick mitochondrial lineage haplogroup predictor. It's a pretty good haplogroup predictor. I like it a lot. So U8 is the mitochondrial lineage, but here on the spreadsheet for copy of ancient DNA 2.07.40, I've noticed there's a couple of errors on the spreadsheet. And this case, this individual is actually one of those errors where on the spreadsheet it says that the individual has got YDNA K2A, and that really confused me because it's a female. I have the file and it's a female. It doesn't have a YDNA, but on the spreadsheet it says K2A, and I was actually researching online to find out how come the sample I have is a female, but here on the spreadsheet it says YDNA is K2A, but I couldn't find any source on the internet that would mention this would be a male or that would mention its YDNA. So whoever decided to write down K2A1 for the YDNA here, uh, obviously they had their reasons, but it is not the case. It is not a male. It is a female. So it's somebody without a Y lineage. But there's occasionally some errors here. This spreadsheet is pretty good, but there's occasionally some errors that you find, and this is one of those cases. The mitochondrial lineage is spot on, though. Mitochondrial lineage is good. Let's go ahead and see what she scores with my ethnic calculator results. So, by the way, in case you don't know like what the time period is, I should talk about that as well. The time period, it's an Upper Paleolithic individual from 35,000 to 32,000 uh, years before present. So, a really long time ago. That would be 32 to 32K years before the birth of Christ, so to 32K years BCE. It's the Upper Paleolithic in Europe. At this point, people who lived in Europe kind of resembled not even so much Europeans or European hunter gatherers that followed, but more so various East Eurasians, specifically people of India. It's kind of interesting. So, with the ethnic calculator, we're going to see that this person is actually closest to Satsurblia Caucasus hunter-gatherer, followed by Gleb Sviatoslavovich, which is this kind of a West Asian shifted person from Europe, followed by Chimera mercenary from the Caucasus, followed by Erfurt Jew, Algerian. So there is a little bit of a African shift as well. Levan Luchta, Afghan. So there's a little bit of a East Indian shift as well. We can see that by Afghan being close. Bactrians as well. That's a little bit of a South Asian shift. And with the Oracle, we can see Levan Luchta plus Syrian Arab. Very interesting. So this person is kind of like this person has some Mediterranean and some South Asian affinities. So, for example, here we see Punjabi Jat plus Syrian Arab. That's another case of the South Asian affinity showing up. There's a German individual plus Australian native in the Oracle as well. So, this is just another case of the Australian or South Eurasian ancestry showing up in the Oracle. So it's just kind of like a all over the place person because they don't really have a lot of the drift associated with any modern people. My ethnic calculator is very much a modern calculator for modern ethnicities. And this is an Upper Paleolithic individual who doesn't really have much in common with modern Europeans or even modern Indians for that matter. It's just a little bit more similar to Indians than to Europeans, but it is not really similar to either. Let's put it this way. Let's go ahead and check what they score with Nashakot and what they score for the appearance. So let's go ahead and see the phenotypes closest to this individual are this, followed by this, followed by this. So quite South Eurasian phenotypes. The first two are South Indian phenotypes, and the last phenotype is a Melanesian or an Australian native phenotype. All right. I think at this point it is commonly accepted knowledge that um, all of these early Europeans in the Upper Paleolithic were mostly of um, South Indian or Australoid-like appearance. And with the two-way models, we see models like this. The first closest model is this. It's basically a mixture of this light version of Australoid plus half this South Indian. The second closest model is once again this light version of Australoid plus this darker version of South Indian. The third closest model is this lighter version of South Indian plus this darker version of South Indian. The fourth closest model is this lighter version of South Indian plus this darker version of South Indian. I wonder what's the difference. No, I see the difference. The difference is that this version has even lighter skin than the previous one. And the fifth closest model is this really dark, wide nose version of Australoid plus this darkest version of South Indian. Very interesting. I don't really know what they score. Like this is my first time seeing this sample. I don't look before I make the video. I'm kind of filming my first reaction, right? So based on them scoring all of these mixtures, I think their hair is more likely to be curly or kinky because of all of the phenotypes that they score. They all have curly hair, so I think the hair is going to be curly hair. For eye color, it looks like their eye color is darkest brown. Brown is also quite possible, but most likely the eye color is darkest brown, and they don't really have any likelihood of eye colors lighter than brown. For hair color, it looks like their hair color is black. They don't really have any likelihood of head colors lighter than black. For skin color, their skin color is light brown, which is something that's a very typical score for any Southeast Asian or Australian or a Melanesian. They all score light brown skin. So in his case, it's probably a little bit darker even than light brown. It's probably like medium brown skin tone. And for hair texture, it looks like he's scoring kinky hair. Very interesting. So kinky hair, curly hair is also quite possible. Wavy hair is maybe not so likely, and straight hair is completely out of the picture. So most likely this person also has kinky or curly hair, which is very interesting. All right. For coloring related variants found in the file, it looks like there is no BH3, there is no BH2, there is no BH1. However, he does have two light color variants in this variation of Oka2, and it says Herc2 on the screen, but it's really Oka2. And this does play a pretty big role in the prediction of eye color. So this does lighten eyes a little bit, and it is also predictive of BH1 to some extent. This is a better predictor of BH1, but this variation also predicts BH1 to a pretty major extent. All right, he's not genotyped for this variation of SLC24A5, but if he was, he probably would not have any light color variants here. So most likely he does not have light color variants in this variation, but we don't really know that for sure. And he does not have any light color variants in SLC45A2, so definitely darker pigmentation of eyes, hair, and skin. No light color variants in this variation of IRF4, so he does not have the European hunter-gatherer blue eye, pale skin, and red hair variants in IRF4. And he's got two light color variants in these two variations of Keto G, so this actually contributes to a lighter pigmentation of skin. These two genotypes make a big contribution to light skin, and they are part of the reason why he scores. They're part of the reason why he scores light brown instead of dark brown for the skin tone. And for the MC1R, it looks like he does not have any variants for ginger or for predisposition to being ginger. So no predisposition to being ginger. All right. Now let's go ahead and check his polygenic risk scores and what kind of traits and illnesses he has. Well, let's click on the polygenic risk scores right now, and it looks like he's got a very high odds for. I'm saying he, it's a she. Wow. Have I been saying he the whole time? That's crazy. Yeah, so she's got um she's got a above average odds of bipolar type 1. She's got above average odds of schizophrenia, which these are very related. Like bipolar type 1 and schizophrenia, a lot of the SNPs that go into the prediction for bipolar type 1 and schizophrenia are the same SNPs. So for these two traits, a lot of the times it's the same SNP. So that's why the scores, if you have a high score for bipolar, you're also probably going to have a high score for schizophrenia, and the vice versa. It goes both the ways. It looks like she's got a average score for type 2 diabetes. Looks like she's got a below average score for Alzheimer's. Well, I can't believe I've been saying he the whole time. That is so awful. That's so awful. Okay. And she's got a slightly above average score for multiple sclerosis. All right. Looks like she's got 2 risk factors for breast cancer out of 12, which is pretty good. 8 risk variance for testicular cancer out of 18, which is also pretty good. 0 risk variance for celiac disease out of 10, which is pretty good. 0 risk variance for GSS out of 4, which is pretty good. 4 risk variance for Crohn's out of 24, which is okay, but we're going to explore that a little bit later. 0 risk variance for Riefenstein's out of 2, which is pretty good, and 2 risk variance for Parkinson's out of 18, which is pretty good once again. So it looks like there's pretty good stuff. She doesn't seem very unhealthy. The only unhealthy thing is, I guess, the score for schizophrenia and bipolar. All right, so for the results from mental health section, looks like she's got med genotype in COMT. Very, very interesting. So she's a warrior in COMT, and she's also a warrior in MAOA. So she's warrior in both COMT and MAOA. This is actually a very European genotype to have, being a warrior in COMT and MAOA, and it's a genotype that leads to slower breakdown of dopamine, therefore higher dopamine levels in the brain. And she also has got GG, which means no derived, no goal events in the pro 19 pro, which means more dopamine Z2 receptor sites in the brain. And she's also got this genotype, which also leads to a increased number of dopamine Z2 receptor sites in the brain. And it's actually, this genotype actually has a really big impact on the score for schizophrenia, as well as this one. And she does not have A1 allele and TOC1. So what this really says is that she's, in terms of ADHD, she probably does not have ADHD. This is not like a typical profile for somebody with ADHD at all. This is like the opposite of ADHD, and in fact, it's kind of a little bit of a risk for schizophrenia, the other side of the spectrum, because so much dopamine Z2 receptor sites in the brain plus so much dopamine in the system that can lead to stuff like psychosis or mania, right? So it's kind of like the opposite side of the spectrum, where on one side you got ADHD, which is less dopamine activation and less dopamine in the mesocortical pathway, and then on the other side you got like mania, which is the opposite. So in her case, she's got a predisposition to mania, I would say, based on what I can see here. Okay, and it looks like wow, she has long form 5-HTTLPR. Wow, that's really cool. Okay, so she's got this gene type which leads to long form 5-HTTLPR. That's really epic. Long form 5-HTTLPR tends to be a European thing. But she's not a European, and I guess she is a European because she's from Europe. But in terms of her autosomal ancestry, she's not really European, and it's interesting that she has it. And um, basically, long form 5-HTTLPR, it's a repeat in the serotonin transportation gene. I forget what it's called. And if you have the long form of this repeat, if you have a duplication there, that means you're gonna have some easier time transporting serotonin, basically, and that leads to a reduced risk of depression, which is really cool to see. And she's also homozygous minor allele at ADCY2 gene associated with bipolar disorder, which is pretty interesting. Once again, we're gonna skip autism for DDC. We're gonna skip that. For lactose persistence, looks like she does not carry the European lactose persistence mutation. All right. For OXTR and the empathy gene, it looks like she's got two sociopath variants for reduced OXTR expression. All right, that's unfortunate. So it looks like she's got lower OXTR expression and lower empathy. All right. For diabetes, we remember she was scoring pretty much average for type 2 diabetes, but she also does not have type 1 diabetes, which is really good to see. For hemochromatosis, she's not a carrier for the C282Y hemochromatosis mutation, which is once again really good to see. For Alzheimer's, looks like she doesn't have any risk variants in APOE, which is really good to see. For multiple sclerosis, looks like no HLA variants for multiple sclerosis. All right, really good to see. For cardiovascular disease panel, we're gonna skip that. I don't really care about this. For myopia, wow, another extremely European genotype. Look at that. She's got a lot of extremely European genotypes, which is kind of interesting because she's not even all that European in terms of ancestry. But she's got this genotype for myopia, which leads to a significantly lower risk of myopia and greater quality of eyesight. She's got GG here, and the G is kind of this European allele that's pretty much mostly only found in Europeans. I'm saying it's not only found in, I guess it's mostly found in Europeans, right? And it's pretty important to reducing the risk of myopia. So in her case, she definitely has a decrease in the risk of myopia. Although she actually has all these genotypes, which also increase the odds of myopia. So I don't know, but she's got GG here. That's the most important part. For miscellaneous section, no micropenis. All right. Well, micropenis is off the table when you're a female. Anyway, but also no micropenis. Also good to know. Better performing muscles likely sprinter rather than endurance athlete. All right. One fat gene variant and FTOs RS9949609. High odds of obesity and sleep apnea. She seems to be a little bit predisposed to being overweight. Same as me. I have the same genotype here. I wouldn't say I'm very predisposed to being overweight. I am overweight, but not because I'm predisposed to it. It's because I. Oh, let's skip that topic. It looks like she does not have photic sneeze reflex, and it looks like she's got one variant for increased pain sensitivity in SCN9A. And for EDAR, look at that. That's actually very interesting. So she's got AA genotype in this variation of EDAR, which means no shovel-shaped incisors and not East Asian in ancestry, but she's got CC here. And she's got an East Asian genotype in this variation of EDAR, which is the secondary variation here. That actually you will not find services online that look for it. It's only my trait predictor that considers it at all. Although I think it's on GWAS Central. So this genotype leads to likely some East Asian facial traits and most likely not European ethnic background. So this is one of those revealing qualities that she probably is not a modern European. She's got all of these genotypes that are very typical for Europeans, but this is kind of the reveal. This reveals that she probably is not really a European, because for Europeans this is very very uncommon. For drug response, it looks like she's got a nothing interesting here. Okay, for albinism and typical traits panel, looks like she's not a carrier of any of the albinism mutations. All right, for familiar Mediterranean fever, no risk evidence for familiar Mediterranean fever. For MTHFR panel, she's got digin type, which is really bad. Basically, a crazy decrease in efficiency of processing folic acid and high odds for a variety of illnesses from autism to coronary heart disease. This is the MTHFR gene. For cancers panel, it looks like she's got genotypes that reduce the risk of testicular cancer, which is really good. For leukemia, it looks like she's got genotypes that reduce the risk of leukemia, but there is one genotype that slightly increases it. All right. For rare diseases and traits panel, this is pretty cool. So she's got TT here, which means a increase in risk of rheumatoid arthritis and 1.5 times increased risk of systemic sclerosis, which is very interesting. I have the same genotype here actually, and I don't know the ethnic implications of it, but it's pretty rare. No risk variance for San Filippo. Yeah, I actually added San Filippo to my rare diseases panel. I don't know if it's gonna be found with. I don't know if you're gonna find risk variance for that in My Heritage or 23andMe or Ancestry files. I'm not really sure. I don't think I've seen that before in the results, but it is a part of the calculation. So some samples theoretically can score risk variance for San Filippo, but I don't think I'm gonna see that anytime soon. All right, no von Gerg's disease, no, not a carrier for variants for Bloom syndrome, and pretty good, pretty good. For celiac disease panel, looks like no risk variance for that. For allergies, we're gonna skip. For androgen receptor gene, looks like she's got typical or higher odds of baldness. All right. Crohn's, nothing relevant was found. All right, so we can breathe safely. She was scoring 4 risk variants for Crohn's. None of them are in the important variations. So okay. Canavan syndrome panel looks like 0 risk variance for that. For HIV and AIDS panel, looks like she's got 0 protective variants from HIV and RS 996494 too. All right. That's kind of a bad genotype. So she doesn't have these alleles that protect from HIV. And muscular dystrophy myopathies looks like she does not have any risk variance for muscular dystrophy myopathies. Really good to see. Color blindness panel looks like 0 risk variance out of 2 in OPN1SW, but unfortunately, this is the only gene that has any data for her. The other 2 genes simply don't have any data. For FTO gene panel, it looks like she's got. Oh wow, she's actually homozygous for fat gene variants for the most part. For the most part, she's homozygous for it, so she's definitely a little bit predisposed to obesity. All right, and here she's got AA, which leads to lower odds of obesity, and here she's got TT, which leads to lower risk of obesity and insulin sensitivity. All right. FTO is a little bit more important in terms of its effect, in terms of the effect it has. So she's probably still a little bit predisposed to being overweight. For syncope, it looks like based on 3 S&Ps, she's got a slightly below average odds of syncope. All right. And let me zoom in at the bottom. It looks like she's got the gene type which lead to high risk of male pattern baldness. This gene type leads to intermediate predisposition to anger. This gene type leads to significantly shorter telomere length and lifespan. Unfortunate. This gene type which also leads to shorter telomere length and lifespan. Once again, very unfortunate. 2 copies of the hunter-gatherer CL1 gene variant. Very interesting. Which leads to reduced ability to process carbs and sugars. This is actually quite interesting. I researched this variation, and apparently there's basically 2 variants. One is the hunter-gatherer, and the other is the farmer variant. And the reason they're called that is not because they are most commonly found in hunter-gatherer populations or whatever, but actually because the hunter-gatherer variant has a functional has a functional ability to help you process meat, whereas the farmer variant has a functional ability to help you process carbs and sugars. So that's why they call it farmer, because one is more helpful to a farmer lifestyle, whereas the other is more helpful to a hunter-gatherer lifestyle in terms of the genotypes. So in this case, this individual has the hunter-gatherer variant, which leads to reduced ability to process carbs and sugars. Probably would not do very well on a farmer diet, and it is quite interesting. I wonder if I'm gonna see. I just added this like yesterday. I wonder if I'm gonna see like hunter-gatherers from Europe with the farmer variants, or if I'm gonna see European farmers with hunter-gatherer variants. If I ever do European farmers again, I'm pretty sure I finished those, but um, it's quite interesting. She's got a hair which leads to reduced risk of rheumatoid arthritis and IgA neuropathy. All right, and she's got digital type, which means no increased protection from age-related maculopathy, very typical genotype. And here she's got. Let me zoom in. Here she's got normal genotype, which leads to lower odds of heart attack and obesity. All right. Well, that's pretty much all there is to this sample. Thanks for watching my video until the very end. Leave a like and subscribe if you enjoyed it. And also, you can download this file in 23andMe format from link which is in the description of the video. Thanks for watching. Goodbye.